Okay, good evening, everybody. Welcome back, 2025. Hope you all had a good Christmas and wish you all a good 2025. So we have a few speakers here tonight, but before the main talk on tunnelling through the Alps, I'm going to ask Mike McConnell to come up and say a few words. Mike's been doing some fantastic work promoting the British Tunnelling Society, and in particular, the 50th anniversary book. I'm sure most of you know Mike. He's a regular attender at these evening meetings. Brief history: he graduated from Queen's University in Belfast, worked with Taylor Woodrow and Balfour Beatty. He's also an ICE reviewer, been responsible for graduate development program within Balfour Beatty, and since he's retired, he's been involved in many projects, including setting up a liaison with Bagner Grammar School, School's Career Advisory Service, and working with expats living in the London area. Okay, so Mike, if you want to come up, say a few words, please.
Thanks very much, Mr. Chairman. Is the mic on? Can you hear me okay? Yes. Okay. Yeah, thanks very much for the opportunity to have a slot in your meeting, John. It's very much appreciated. And also the hard work that the whole BTS committee have been involved in the past year with our infamous book that is now being widely published and received by a wide range of people. So it was a bit of an insight for me, if you like, to really see the hard work that goes on behind the scenes in the BTS committee. So thanks very much for that opportunity. And also, I develop a bucket list every year, something significant. And this year, it was to head for New Zealand. And I thought I would combine the two things, if you like, to actually link up with the New Zealand Tunnelling Society. And very kindly, that was arranged for me. And it was very nice to sort of have that link up. So this is just a view of Auckland from the North Shore where I was staying, basically. This was the itinerary, basically. The 10th to the 24th of October in New Zealand. And it was interesting, we got just around 100 members for this evening, for the Thursday evening. The downside was I flew in at 3 a.m. in the morning and we were on parade at 6 p.m. that night. But that was a minor detail, but it was really lovely meeting up with all these good people. And also a number of the senior members of staff who had worked for Balfour Beatty on overseas international hydro schemes, and they were able to link up and receive a copy of the book. So that was what was happening there. And then when I came back, it was over to Northern Ireland for some trips to my old school and Queen's University, Belfast. So this was us then at the actual meeting. They actually hold their evening in pubs, funnily enough, with a very good annex room for plenty of activity. And they seem to feed you with food all the time, basically. And the beers would come through from the main bar. So it was a very convivial atmosphere sort of thing. And even the ICE council member for Asia and Pacific area, he came in to join us. So this is the first presentation here to Tom Parker. His father sadly passed away 8 years ago, and he was very much a central player as a general manager in our international business. And it was Tom who sort of set up all the liaison with the local tunnelling society. And that was fantastic, the work he was doing. This is my old colleague, Herb Hart, who he's been in the business for something like almost 50 years, 10 different countries, mainly in the Middle East and the Far East. And he certainly deserved the book. And it was a real pleasure meeting up with him. I had a bit of a speech prepared, but I soon kicked that into touch. It was much easier just to have a conversation with him. And I think that was the order of the day there, along with some of the other friends. That was them. We're in Christchurch now, actually, down there, and that was the rebuild of the new library in Christchurch, which is quite good. The downside was it was actually an Anglican church in Christchurch. This was the 2011 earthquake, and this is the order of structural steelwork that was necessary to stabilise this building. But they got this thought process about the They're actually stabilising a portal like that to support the rest of the building. But it was, the money it was costing was so much that the government were saying, sorry, you're going to have to make this building more accessible to other people, not just your particular church religion, as it were. So there's a bit of a fight going on there. This is, I was determined to get a rugby pitch going here. This was the new stadium in Christchurch that's being built there. And that seemed to be a lovely bowl of an arena that's going up there on that. I've put this one in just for you to appreciate the two styles of payment. An awful lot of town planners and architects involved in all this refurbishment of Christchurch. And it really, you can see the two different types of construction. The one in the foreground there was what these town planners were suggesting was a much wider pedestrianised area on that side. And similarly on the other side of the road, what they didn't quite realise was that the actual effective width of the road was getting narrower. And of course, the same amount of traffic wants to come through, and they didn't have any shuttle buses or anything like that. So I have to be a bit sceptical about that. This was looking down just north of Christchurch at the coal terminal there coming in. And a lot of that high-quality coal has been exported to China. So the Chinese have got facilities there for actually exporting all that, while meanwhile in New Zealand they're bringing low-grade coal for domestic use from Indonesia. Herb is pointing out here a chart here that was showing, sadly, those that got killed in this mine disaster in 1967, and he had to identify, unfortunately, the bodies, and it was really quite sad. But nobody greater than Herb to sort of see and realise the way that can get helped out. This is a viaduct that we were driving along, and I was determined to take a photograph here because what it was the old road was coming along something like this and then coming out here. So this viaduct was constructed, and fantastic, that stayed stable in the earthquake. But then when I look at the name of the actual person who was involved in the construction, I won't advertise it too much, but it's somebody called McConnell. Now, I just felt I had to take that photograph, but I can assure you I had nothing actually to do with that bridge. Again, Herb, the tunnelling manager who got one of the books, was in the coal mining business, and you can see in his garage he would keep the old Davy lamps there that would be spotting the build-up of methane in the tunnels, and the old, and the old lighting lamps up there. So he had quite a store in his garage of all this material here. I'm not of the right age to be climbing up glaciers from sea level, so I thought I'd get the chopper up. Got the chopper up, but then the lady pilot, there are three other guys in there, said, or I said to her, I said, this cloud seems to be building up quite a bit here. Shouldn't we perhaps be thinking about getting back down to sea level again? And she very quickly realised that was a serious thing, so we whistled into the cab there and got down, and she then was able to take the chopper down in the valley down there and not risk getting stuck up there for the evening, as it were. I was very proud of this, to actually get a royal invite into the All Blacks home ground there at Eden Park. That was one of my bucket list aspects, if you like, to actually sort of see the business there. And it was the son of Herb Hart who fixed this all up for me in about 5 hours. Fantastic. So again, one on my bucket list was to go out in the Americans Cup. This was about a 10-year-old Americans Cup yacht there. But unfortunately, when I went down there, the main boom, as you can see, it's all lashed up there. And it was 28 knot wind blowing, and they didn't want any public to be going out in it. And when I saw what was happening there, I was quite relieved, to be honest, because I didn't fancy going out there for 2 hours on a very slippery surface there with these grinders, they call them, for generating power and bringing the sheets in and out. So I was very glad in a way, actually, that didn't actually happen. So this was a further presentation at my home school with the headmaster there. And then that was a presentation up at Queen's University there with one of the books. The library only had 1.4 million books, and it was only 1,000 workstations in that library. And I shouldn't say this, and I'm quite sure this isn't true, but I got the impression that the students were coming in there, especially on the night shift. It was a 24-hour operation. So I got the impression they were coming in for the heat to reduce their bills in their flat, as it were, for the heating costs. So they were working on a 24-hour basis in the library. I thought libraries were just for borrowing books, but it's very much a work centre that was going on there. And then we were working closely with Queen's, And what we're doing for the actual book that we now have, we're trying to get these, call them if you like, keywords, if you like, allied to the book. It already had civil engineering as a category, and it also had tunnelling as a category, but they've now agreed to introduce these further tracking measures within the actual book, so that when this, if it does eventually get linked up with other networks in the UK, it'll be an easy thing for students to find their way around, or if they want to see a book that has these elements in it. It's not saying they can actually see it all online or anything like that, but it's giving the broad contents of making it a more interesting read, if you like. So that's the sort of theory there. And then at the grammar school, again, it's very important, I think, to personalise these books. So on the inner page, it helps, I think, if you actually put an actual introductory memo or something, particularly about that school or about the kids who might be seeing it or something, and introduce the keywords situation as well, and make sure that the careers department actually have got some knowledge of what's in there and try to be selective in what they're showing the kids, because they could perhaps be put off a bit. There's so much information there. Sometimes I think you have to be a bit selective, as it were. And also at the end of the book, if you are going into a school or whatever, it's, excuse me, it's very interesting to see things about articles that are anticipating into the future situation, and also for females in the industry. I think we're in that situation now, and there's some nice articles in there too. So do make sure whoever's actually reading the book to actually go right through to the final pages. It was interesting actually, John, whenever I read through it, there was some work in Belfast that you were involved in that I saw there. And I also was very interested to see the pubs that you actually named there, because they were the same pubs as a tearaway student that I used to visit. So it's just interesting that there's a bit of a connection with Belfast in the book there. But I won't incriminate you any more than that. So I think that's really just the sort of quick run through I wanted to give you before the main act comes on, as it were. What I personally think is that there's still a lot of potential for this book being allocated into universities. And I hope some of you are still interested in perhaps buying one more book it doesn't have to be the particular university that you're from or whatever. One that could be just quite close to you, or a school. And again, you don't have to have been at that school. It's just if you happen to be living that area, you can develop some catching up with the head of careers department or with the principal themselves. And in fact, with the university connection, try to make sure that you can actually link up with a professor of the faculty or whatever, so that the book gets a good read, as it were, from the point of view of advertising through the head of the faculty as well. So those are just some of the things that I would like to mention. Could it be very cheeky just to show a very quick pair of hands in terms of if you still think that it would be a nice idea to buy another. They unfortunately have gone up to £65, but the hearing I get now is it's still very good value for money. And the word amazing comes out from a lot of the people I've been dealing with in the last number of months. So could I just a show of hands of anybody who's still interested in buying one book, say, that they could allocate into a university or a school without commitment of any sort? I can't. 1, 2. Okay. Get the message there. But I think that's the way to leave things at the moment, Mr. Chairman. Is that?
Yeah, and you'll be in the bar after?
Yeah,
selling books.
If there's any other question in the bar, please just contact me.
Bring your credit cards.
Sorry?
Tell them to bring their credit card to you.
Absolutely, as usual. Thank you.
Yeah, thank you, Mike. As I said, Mike's done fantastic work promoting the book and continues to do so as well. So, okay, we'll move on to our main presentation this evening, and it's about tunnelling through the Alps. So we have 3 speakers. Emmanuel Humbert, who's the Director of Construction, France Direction with TELT. Emmanuel holds a master's degree in civil engineering from the French National School for State Civil Works. He worked in the tunnelling industry for more than 2 decades. After working for nearly 15 years in the Centre for Tunnel Studies, the French government's technical centre for road tunnels, he joined TELT, owner of the Lyon Turin tunnel, as head of the construction department, where he coordinates work on French construction sites. His experience includes road and rail tunnel construction and has been accumulated over the course of many tunnelling projects as a project engineer or project manager. He has developed extensive professional skills in tunnel design, geotechnical engineering, and project risk and contract management. He's also a lecturer for postgraduate courses at French universities on the subject of tunnelling and tunnel boring machines. Emmanuel is involved in the ITA and is active in the French Tunnelling Association. Second speaker is Adrian Fontana. He's head of construction management with the Pinney Group. Adrian has been significantly involved in the construction of the longest tunnels in the world for the past 20 years. The Lochberg Base Tunnel, the Gotthard Base Tunnel, the Sanary Base Tunnel, and the Brenner Base Tunnel. His experience covers all phases of design, and he held all relevant functions up to the project manager at the Sanary Base Tunnel and the Euralpin Lyon Turin Tunnel as a consultant to the client. Adrian is an expert in contract management and processing. He contractually operated the complex major construction sites on the Transalpine rail link in 3 languages, French, German, and Italian. Thanks to his extensive knowledge in underground construction, he now has a universally recognized expertise and leadership skills. He joined Pinney Swiss in 2007. Since 2020, he has been a member of the Pinney Group Executive Board and head of the Construction Management Division. He studied in the USA and Freiburg and holds a degree in civil engineering ETS. He is a Swiss citizen. His main references include the Lochberg Base Tunnel in Switzerland, 34 kilometers, the ATG Transalpine Transit Sanary Base Tunnel, Switzerland, that was 15.8 kilometers, and the BTS Brenner Base Tunnel in Austria, 57 kilometers. And our third speaker is Benjamin Leconte, Technical Director with the Vancy Construction Grand Projects. Benjamin has experience working on international underground projects for the past 19 years in various technical positions with Vancy. He has an extensive background in rock mechanics, geotechnical and deep underground works design. He is currently the Technical Director of the huge operational site works C67 on Tunnel Euralpin Lyon Turin project below the Alps mountains with its 46 kilometers to excavate. With an underground works designer background, Benjamin has worked on more than 40 major projects involving bored and drill and blast tunnels, cryogenic and scientific experiments, sometimes from the tender phase to the end of the construction phase. Recognized by his peers for his ability to solve complex and challenging technical and underground design issues, he is a holder of the prestigious Structures and Works aggregation of the École Normale Supérieure de Cachan, the highest teaching diploma in France. So I'd like to bring our first speaker up, please. And can I just emphasize if everyone can sign the signing in sheet, please, as well. And the seats at the front if anyone wants to come and sit down. Thank you.
Thank you very much. Thank you for giving us the opportunity to present this challenging project. I think it's one of the most challenging projects in France for sure, in Europe also, and perhaps also in the world. As it was said, this presentation is split into 3 parts. One overview of the project, I will present it. I'm the owner of the project. One focus on the designer's point of view with Adrien, and also the company point of view with Benjamin Leconte from the company. First of all, the project overview. This project is led by TELT. Maybe you don't know who is TELT. TELT Tunnel as Tunnel Euralpin Lyon Turin. is the promoter, the public promoter of the project. And I work for, which I work for, and for which I am the construction manager. And I personally am in charge of organizing and following all the works on the French side. So TELT was created in 2015 by French and Italy states and is responsible for design, construction, and operation of the cross-section of the future Lyon Turin link. So what is the Lyon Turin link? You'll see a little bit later. This society follows other previous company, LTF, that was in charge of the studies, investigation, and preliminary works. And also, a little bit earlier in 1994, also with Alps Tunnel, which was in charge of the very beginning of the studies. Above all, the Lyon Turin link is not a project between Lyon and Turin. Above all, it's only the Lyon Turin link is in a certain way only a part between a wider project between all the Europe. The idea is to create a global network, efficient global network through Europe, and the Lyon Turin, which is here, is one of the parts of this project. This project is composed by nine corridors, and Lyon Turin is in the center of the Mediterranean corridor. So why Lyon Turin is a so challenging project? Because of the Alps, because it has to cross the Alps. The global part of this line between Lyon and Turin is 270 kilometers long and is split into three parts also. One French part here, which is conducted by the French railway company. One Italian part in the same way, which is led by the Italian railway company. And also the cross-section, the international section here, and TELT, my company, is in charge of organizing the construction in this part. So the principal challenge of this project is to pass through the Alps. An historic line already exists, but is fully inadequate. Because of its characteristics, here is the historical line, the geometry also, and the idea of this project, because other projects in Europe exist in the same characteristic, is to pass through the Alps at the base of the Alp. Here, the idea is to create an efficient infrastructure which permits to boost the communication of freights and passengers and peoples all through Europe. So I said other kind of project exists. There are 7 long and deep tunnels under the Alps. And the design of the Mont-Cenis-based tunnel, that is its name, Mont-Cenis-based tunnel, is based also on the experience of the other tunnels. Some are under construction and others are already constructed. The 7 tunnels are the Mont-Cenis-based tunnel for the Lyon Turin project, but also the Gotthard-based tunnel, the Chennery-based tunnel, the Lodgeberg tunnel, for which Adrien also worked previously, the Brenner-based tunnel, the Semmering-based tunnel, and the Coram. Let's focus on the cross-border section, which is the perimeter of responsibility of TELT. The cross-border section is 65 kilometers long and begins in Saint-Jean-de-Maurienne, here, with the link with the French National Railway network, and also with Bussoleno, here, with the link with the national network in Italy. This section is composed, obviously, by the emblematic tunnel, here, the 57 kilometers long tunnel, one of the longest tunnel in the world, when it would be completed, but also on open air section here to make the connection with the existing line, and also in Italy the same. There are two international stations, one in Saint-Jean-de-Maurienne here, and one in Susa, in Italy here. The layout of the tunnel is a double track tunnel, and each tunnel is about 43 square meters carrés of section. There are 3 safety stations underground, one here in Lapra, one here in Modane, and one here in Italia. There are also 2 safety sites outside at the portals of the tunnel, one here in France, one here in Italy. 4 ventilation shafts here in the center of the project, and other equipment for maintenance and operation, cross passages, sidings, and also other declines to access to the safety security sites. Globally, all the gallery represents more than 164 kilometers of galleries. It has 3 underground security sites, more than 204 bypasses for security, and so on and so on. The layout of the tunnel is designed to permit high-speed train through the Alps at the speed of 220 kilometers, but also the passage of local trains, truck, and obviously rail freight. So how the construction is organized? The construction is organized with 12 lots of construction, 12 lots of construction that each represents a part of the project. This choice has been made depending on the access that was permitted by the adits. Here, there are 3 adits realized in France, one here in Saint-Martin-la-Porte, one here in Lapra, one in Modane, and also an exploratory gallery that was realized in Italy, here. And between all this access, there is some works to do, and the lots of construction are divided depending on this access. So what are the current work today? This scheme represents a symbolic view of the tunnel, and what is in yellow, in bright yellow, is already done. So today, all the edits are already done, but also some parts of the tunnel, and especially a part that was realized 5 years ago to test the real conditions of a TBM in such difficult underground. Today, also, there are more than 10 sites where works are ongoing. Here in Saint-Jean-de-Maurienne, here in Avrieux, here in Modane, also in Italy, with the displacement of a motorway place. In Chiomonte in Italy, for the tunnel de base, for the waste site in Italia, but also for the main tunnel in France, Saint-Julien-Mont-Denis, Lapra, and Modane. In France, and also in Italy, today all the contracts are awarded. The first were awarded in 2021 in France. These are the principal companies that have awarded the contracts. And the next presentation will focus on this contract, on this project and this part of the project. But today, all these contracts are awarded also in Italy. Next step will be to do these things. The 2 stations, the internal station in France, Saint-Jean-de-Maurienne, but also the international station in Italy. And to finish, because the call for tender is ongoing, it is also the contract for operation and maintenance. We have made a choice for the civil works to do some classical contracts with design build. But for this one, for operation maintenance, we have made the choice to make a more global contract, which is a mix between design build and also which take consideration of several years of maintenance. Some figures of the project before a quick overview of what is ongoing today. 113 kilometers of exploratory site investigation. That's what was needed, and that's today is a precious treasure for realizing one of the most challenging projects through the Alps. Today, a little bit less than one quarter of the project is realized on 10 construction sites. All the contracts for the civil works are ongoing. 5 TBM are ready to be assembled and manufactured today. And today, more than 2,500 persons are at work. So let's have a quick overview of the works. So this video is not quite up to date, but has been made 6 months ago. Here in Italia. The entrance of the work in Italia, Piemonte. And all the preliminary works to make connection with the motorway, actually ongoing. The preparation of the sites for materials. Italia also. Here in Modane, a road to avoid the trucks to pass through the city, and also the preparatory works of the 4 shafts to bring ventilation for the next of the project. Saint-Martin-la-Porte and La Prat, which will be presented a little bit later. Saint-Julien-Mont-Denis, the entrance of the tunnel in France. Saint-Jean-de-Maurienne, where lots of works are ongoing to connect with the existing railway network. And also one specificity of the project, the management of excavated material, which is specific lots of construction. So today, on a global amount of 173 kilometers of gallery to be done, we have realized almost 40 kilometers of all this. In colors, in this picture, you'll see what is actually done. Finally, to introduce the next presentation, I will take a little bit about the contract. What is the spirit of our contract? The spirit is to divide to have a sort of risk-sharing policy in our contracts. The principle that will be developed in the next part of the presentation is that on the one hand, we have the logistical and construction method risk that is assumed by the company through the contracts. On the other hand, the owner keeps the risks defined for the geology through the risk register. A little bit a quick view on the timing. It's not fully up to date, but it's quite real in principles. Today we are here. We are in civil construction, as I said. All the civil design has been done, the exploratory also, and all the studies. We are in depth in construction phase, and we already began to work on the equipment construction phase, and also the project is also the phase of maintenance until 2131. Thank you. Adrian?
Thank you, Manuel. Okay, I'm going to talk about the main lot, one of the main lots, the CO67. It's a lot 2. It's, I think, one of the most interesting lots. It's normally because I'm working there, but it's a technical lot. We have a lot of problems. It's a main challenge for logistics, for technical engineering too. And there we see every day that we are constructing a prototype. The longest tunnel of the world is always a prototype. You never know everything. You never know what the geology holds for you behind the next tunnel phase. And I'll just try to show you a little overview about that. Okay, this main lot. From one to the end, we have 23 kilometers. And altogether, we have to excavate 48 kilometers in total, with caverns, with different cross sections, and caverns, logistic caverns, and so on. I'm working for a joint venture. The engineer, they have the construction site management too. It's 2 French offices, Set Existra, Italfair Italian, and Pini Swiss, a Swiss design company. Owner TELT, Emmanuel is representing the owner. Okay, this is what we have to build. We have to build a tunnel, you see, with the safety station in La Prat. We have 2 accesses, one in La Prat and one in Saint-Martin-à-la-Porte. Means we have 2 construction sites. And the difference when you go from the outside, it's already almost 20 kilometers. You have to take the freeway to go over there. It's not that you just go fast over there. No. It's like a half-an-hour trip. And with all the safety stuff, you have 1 hour to go to one side to the other. Okay, these logistical problems. We are going to have 3 TBMs. It's pretty nice, 3 TBMs on one construction lot. But what we always forget, we have a lot of drill and blast that you have to excavate. And this actually is the most difficult part, actually, on the construction site. The TBMs, one is in we are assembling. One is in assembling, it's going to start this year, and the other 2, they are still on the fabric, let's say like that. Then, okay, first, it's really important. First, we had on this site, there were exploratory works that were going on. We had the first TBM part, the TBM part on this section, you see it in the red. And this was really to explore all the geology, to the can we do it with TBMs or not? Because you know how high overburdened. It's always a discussion. Can we dig with TBMs or with 1,200 meters with cover. This is always a big question, was a big question in the other projects too. Base tunnels, Gotthard, January, always the same problem. And here, okay, we do it. The technique is getting further. The TBMs that we have today, they're not the same that we had 20 years ago. The technical issue helps us, and the time helps us to do some challenging projects actually, and do it faster, and it's possible. Because then we had, here you see another picture, this is actually the existing tunnel. There was a single shield who worked for 8 kilometers, and they saw we had 2 faults over there, the squeezing conditions. This actually was the base and the input that we have to do the design for the main tunnel. The Explorer works, just to show you some pictures that they have till like for that squeezing, we're going till 1 meter of squeezing. This is condition that are really difficult to find the support to manage these conditions are really difficult. They try different systems, and at the end the solution was found with flexible support with TH arcs, and that were used in other big projects too. But you see here you see the pilot tunnel to try to take this first squeezing, and then that you can stabilize and do the real galleries. This was the Explorer, these pictures from the exploration. Now we have like 3 machines, 3 TBMs. This one is actually in the tunnel today. Diameter, classic, 10.42 meters. It's a big feather. Really nice, something special. We have a conicity from the that we can manage squeezing rocks. We hope it works. We want to see that in 1 year. And we have some 3 single shields, and you see we have like around 1,200 meters of overburden. This is going to be a big challenge. Just the other 2 ones, we have 1 red, 1 blue, 1 green, and they're going to start this year and next year. Now, what else? That's actually the interesting part now for me. Actually, drill and blast. You have a lot of drill and blast. Drill and blast. It's for me. It's always special because you never know what you're going to have, and the safety part is a big issue too when you have drill and blast. This is one example on the right side. You see a big technical cavern that we have sections for 380 square meters. It's really big. And when you have the bad luck that the geology is not so good, because here we had some problems. You see, this is always a ramp that we had to make to reinforce 160 meter long cavern. We had to reinforce like 50 meters with steel bolts with 12 meter long steel anchors. Maybe Emmanuel is going to talk a little bit in detail from that. But okay, but we know that we have some problems. We have this. We have 2 kilometers of squeezing. His name is Ouillet. It's important squeezing condition that we expected. That's what I said before, till 1 meter of squeezing, and it's going to be actually pretty challenging. And we're going to start in a few weeks. We're going to start in there. I will see. Maybe next year I can talk more about that. But this is like really the part where, you know, the technical issue, how you can calculate all that stuff, and what we're going to really see then on site. You know? And there are some engineers that are really nervous actually when we go in there. But we see. Okay. Now we have the geology, small overview of the geology. We have limestone. And karst on French direction on this side. Then you have some Ouillet. This is this part, this squeezing part that we have. These black schists, really black schists. carbonate and actually really bad. Then you have some known faults that we know. We already know this, that we had this exploration with the TBM from the exploration lot. We know that they are there, and then we're going to have some pre-treatment before we come in and go through with the machines. The other one is a little bit better. We have some where we have the safety station. There we have TBMs that are going direction Italy, and there we have some nice marble, dolomite, and we hope some better geology that we have on the other one. Okay, this is actually some pictures that from last week. What we have, you see the geology on the CO6. This is in Lapra, on the direction Italy. The geology is a little bit better than on the other side. But here we have other problems. We have the problems that we have this safety station. The tunnels are actually really close. You see they're a little bit wider over here because we try to give some space at these tubes. The problem here is going to be that the influence of the excavation from one tube to the other with all this cross section. We have some big sections over here that we can evacuate all the people, that we can hold the train and evacuate all the people. And here we have the thing that we have to really watch out is the influence from one excavation to the other. And when you're in there, you have excavated the central, and you're going on the left side, and then it's going to start moving on the other one. No? And this is tricky, always tricky. This is the other one, some pictures. Here we see this cavern, technical cavern, where we have to reinforce. This is ongoing. We have some, you see we have some scans. The geology is managed with 3D scans to have some better information and to try to be with AI actually too, that we can be more precise for certain interpretation. Let's say like that. Okay, this nice picture. This is direction France. This is a karst. No, this is this karst zone or the limestone with karst. And you see when you have a preliminary exploration, you know, we have a drill like a core drill or a destructive drill. But when the drill is over here, this one you don't see. This is a karst. This is not an excavation. This was the phase. This was a 3-meter drill and blast advancement, and there this was a karst filled with clay. And okay, here is no problem, but when you have this on this side and it's filled with water, can be a problem. No? Okay, this is the whole zone that we have when we go now direction on the French direction. That's really interesting for the geologist actually, but it's pretty tricky, and we have some water too actually. Here was the karst was empty, just clay, but we have some zones where we have water and where we're going to drain the water and put in the mound. Okay, now just fast to what Emmanuel said before. This is actually it's really important. It works. It's based on this norm in Northern Europe actually. It's this risk sharing. No, it's really to try. We are constructing a prototype that we need an instrument how we can work and how we can pay the contractor, how we can be sure that it's not going in big claims and big problem at the end. The projects are really long. No, these projects getting 6-7 years altogether, and you have to resolve it ongoing the project. You can't wait 7 years and then resolve a contract issue. It's really, then it's difficult, and it's not anymore engineering issue. Then we talk about other stuff, no? But this is really share the risk, no, between owner and contractor, and it works actually really good. Owner, the geological risk. Geological risk, why? Because nobody knows what's behind the face. You can do all the exploration, what you want, but you're never going to know really what's coming in the geology. This is the main point. But the contractor knows how his people are working, how fast they are working, what he can do. He's a specialist in the logistics, and he can fix that. No? And then the next step is, okay, you have some class, some support class that we need. It's like a toolbox. No? You have a toolbox and you have like 5 support class, and you can open it when the geology is like that. You open it and you take this support. No, it works really good actually, but for this you need observation, geologists, geotechnical on construction site. They have to be really fast. They have to work together and they have to decide fast. This is how you say, a light one, and this is a heavy one. No, you see, we are working with anchors, with steel arcs, what do you say, shotcrete, fiber reinforced shotcrete, net meshes. That's classical, actually flexible support that we use. When you have big caverns with 380 square meters, you can't work with heavy arches because it's too big. And when it's squeezing, when you have really big movements on this, your heavy stuff is gonna crack. And one thing that I didn't know, they have in France the automatic boulders, actually for the anchors. You know, you don't have people, they have to manipulate in front. They can drill the anchors and put it in and put the concrete or the resin or the chemicals in without manutention in front. This is actually really positive. It's the first time that I see that. I know that in Australia they do that a lot, but in Northern Europe it's not really common today. Here you have some from the toolbox. Now these classes, you see, you have really for everything you have a range, and when you're going out of this range, you change the class. When you change the class, the class support, then you have other prices. You get paid. You have longer time or less time, and all these factors going to be fixed daily, on a daily basis, on the information from the observation, from the geology and geotechnics, and so you can handle actually the contract. No? Because this condition here, the geology is really nervous, is changing a lot, and you have to change a lot these different classes. And when you're in the range, when you have your shotcrete and you made more, like instead of 10, you have 20 centimeters of concrete, and you're going to the next class. And it's paid. You can pay, you know every day what cost your contract. Okay, then, and when this not works, because the prototype, I repeat, is always a prototype, when this classes didn't work, when the designer didn't saw everything and didn't thought about everything, we have another instrument that we can go out. That means that we can enter to this exceptional conditions. Means that all our toolbox is empty. We can use it, and we have to invent or calculate or find something else to get through. Then we have this instrument that we can go to this exceptional condition. Means we are mobilizing engineers, experts, and contractor to find how we can go through. And in this time, day by day, the costs are paid. No? Because when you have a team from 10 people are waiting 8 hours, you have to pay. Okay. Now some pictures, Saint-Martin-la-Porte. This is a picture from this summer. You see access, here's access, tunnel access. You see the conveyor belt, offices. You see lots of stuff. Water treatment here and here. And here is preparing for the TBM. You see already some pieces of the TBM, of the red one. And this is going on today. Here you see these caverns where we had to wide off once. You see this nice geology that we have. Cross-section, always a problem. Cross-section, always a problem because really difficult to calculate, really difficult to know what is coming and the stress, how the stress is going into the mountain. Here you see one phase on the right, one on the left. Beats you have to work on both thighs because you can't work just one thigh because you're going to have a lot of stress problems in this cross section, especially when you have these wide sections. This is Lapra. Lapra, another construction site. The tunnel is, where's the tunnel? Here, over here, you see some steam. It was actually in autumn. Water treatment, offices, and all the material over here. This is one of the axes. When we started the project, one of our thing was that we had to expand one axis because it was too small actually. Here you see we had to work with drill and glass. We went down with the invert for 1 meter 60, and you see the result. You see this one at the end was like that. It's actually pretty nice, no? And now it's like clean, and we have some big, we have a ventilation issue because it's always difficult to put all the air in this system. We had some problems, but we're gonna actually resolve it at least. And here's some pictures just to know that we are really on construction site. No, it's not just for the show, no. And don't forget, here's Emmanuel, no, myself, and Benjamin. And here, not to forget the miners, and we know we have our Santa Barbara, no, or Saint Barbe, a really important woman in our business. Thanks a lot. I'm going to hold over to Benjamin. He's one of the best tunnel engineers in France.
Thanks, Adrian. Before, I will not reintroduce our joint venture, so I will directly move to some safety issues. I will discuss first with fire events, because I understand that in UK you don't have the same approach regarding fire event. So in the past, TELT has signed an agreement between the fire brigade of the valley and on the project. So on our project, in case of fire, the guy who will pick up will be the fireman of the valley. So they are directly involved on our project. They are coming every week. Just the firemen come every week just to check what are the progress of the job now. Just in case of fire, they need to go through. They need to know where is the project now. So they brought also some specification. For example, on our project, we have some rescue chamber every 1,000 meters. Just in case, let's say, there is a fire in the middle of the project, they will be in position to go from one rescue chamber to the other, just to pick up us in case if it is needed. Within this rescue chamber, we have 36-hour autonomy, and at each location, we have at least 30 seats, just to ensure that everybody can go through a rescue chamber. Also, we have rescue chamber close to a working zone with the same strategy. In case of fire, you go to the rescue chamber. The firemen also brought some specification, for example, for the fire vehicle. So it seems like a typical truck, but in fact, there is many specific devices within this vehicle with radar and so on, so as to ensure that these firemen can go up to the fire if needed. Firemen also brought some specification with communication system, so it's something which is quite, it's a little bit used for firemen with firemen in tunnel, so it's so-called Antares. So that means in case of fire, they can discuss everywhere within the tunnel with this communication system. Also, they are coming every week, but at the end also we made some tests. When I'm saying we are doing some tests, we made a fire test with coal smoke in September. So the staff was aware of the date, but the worker was aware that there was in this week a fire event, fire test, sorry. but they were not that aware of when it will be. So during this fire event test, 130 people were confined in the rescue chamber during basically around 8 hours. Then the firemen came to bring them to the surface. Just some picture of this event. So we brought some this coal smoke in a cross passage. You can see then 3 minutes later we could see nothing. And on this side you can see all the firemen we were working to implement, to test the ventilation strategy, all the guys who were in the rescue chamber. And this was a very fruitful exercise, I would say. Maybe just in addition to that, one specification on our project, we implemented a first aid team member. It's a team dedicated to safety. We just ensure that, for example, rescue chambers are fully operational, there is air, food, and so on. All the device communication system is working properly, and they are working 24 a day, 7 days a week, just to ensure everything is okay. Without any transition, I will just jump to other stuff now, more dedicated with logistics. So we are on CO7, on the west part of the project, and when we arrived, so there was an existing adit, one was a west adit, and from this unique adit on 500 meters, we had basically half of the project to excavate and to manage. This adit on this 500 meters, it's basically it's a 80 square meter adit, and within this adit, what we need to ensure, we need to ensure all the muck out of the project, because for different reasons we do not muck from the other site. So all the muck is going through this adit. That means we need 3 conveyor belts. So basically we have around 4 million of cubic meter to remove. Because here we have a TBM, we need to bring all the segment which is going through this adit. We need also to supply basically around 800,000 cubic meter of concrete for the whole site. We need also fresh air because we are in tunneling. We have also exhausted air because of drill and blast works. We have also water. We are anticipating around 400 liters per second on this area and 400 liters per second on the other area at the maximum of the project. So, because here is a low point, so we designed for 650 liters per second of water to be managed, and our water treatment plant is designed for that. So all of this stuff are going through this. And finally, we need also to keep a clearance for access for vehicle. It was a real challenge, and when we went in the detailed design, basically we say, okay, look, we need finally a little bit more fresh air, we need more exhausted air, we need more space for the conveyor, we need more space for the circulation area, we need utilities and so on, and it was a real nightmare because it was not feasible to bring everything inside this first 500 meters. In addition to that, this is a typical section, so it might seem quite okay, but at the end of the day, you need to keep in mind that at some intersection, it's a little bit more challenging. So at this intersection, at PM so-called 500, we need to perform additional huge excavation just to ensure that the conveyor belt is crossing and so on. Huge challenge. And at the end, we say, look, we need another solution because we will never succeed to work properly with such a solution. So the solution was, okay, this is the first 500 meters. Let's do an additional adit on basically around 500 meters. And the idea is with this adit, we will supply all the west part of the project, while on the east part, we will supply with the east adit, we will supply the east part of the project. So we made the design, we arrived with a 70 square meter section. We brought some ventilation issues, some for clearance for the vehicle. We changed also the strategy for the ventilation. in fact, now we can make a circle for the ventilation. That means we bring fresh air here. Within the tunnel section, we go here, and then we go back. The fresh air is doing a loop, and then we can pick fresh air, for example, for this tunnel and everywhere. And that's definitely a game changer, because for us, at the beginning, within this part, with this 14 square meter, we need basically 25 meters per second of air, and it was a nightmare. It was a huge power consumption. So with such strategy, we brought some, it was feasible. So we made the feasibility in spring 22. Then we made some ground investigation, especially close to the portal during the summer, detailed design during the autumn and then to the spring. We needed also a client approval. We got it in December, and then we began the excavation just after, in December 22, sorry. And we finished the excavation some months later. So during this period, we also made some other excavation. That's why for only 600 meters, we need such a duration. But basically, we made other stuff. So this is the beginning of the project within the mountain, and at the surface, close to the portal, sorry, we went with umbrella vault. And here you can see the project once it was finished. So here you can see the 3 pipes. It's for exhausted air. So within this project, everything is beautiful, except that we still have a conveyor belt here. And when we made the detailed design, we forgot that we were expecting the tension unit could be made at the ground surface, but at the end of the day, it's a little bit too long. And on some meters, we have a narrow section for vehicle. Everything is in the detail. Okay, so this tunnel has a cost, basically around 9 million euros, and the question was, who is going to pay? We asked Emmanuel, do you want to pay? The answer was no. Then the question was, do we want to pay ourselves? The answer was also no. So the idea was to find a solution with some optimization elsewhere within the project. And we saw a solution with TBM assembly and logistics on the East Saint-Martin working zone. In other words, this is the East adit, and as per the basic design, we were supposed to do a gallery here, then with conventional excavation, this gallery, then a huge cavern, then we can assemble the TBM. We are supposed to assemble the backup within this area, and then we excavate. After discussion internally and also with our engineer, we found a solution, alternative solution, consisting in saying, look, let's assemble the TBM within another cavern. We have to build for different other reasons. We will rotate the shield and the backup on a sufficient length, and as a consequence, we will save some money. So, from a cost perspective, because we were removing a cavern, which was a temporary cavern, we were saving money. We were also saving this logistic gallery. We also, the cost of linear meter of a bored tunnel is definitely cheaper than conventional excavation. So with that, we were also saving some money. Okay, we have additional costs because of TBM launching within the cavern, some other arrangements. But at the end of the day, we succeed to balance the extra cost of the additional gallery with all this saving. So that was a good beginning. Then we demonstrate that from a risk perspective, it was a good solution because we know that caverns are quite risky, and we will discuss a little bit about that later. So then when we remove a cavern, we remove also some risk. Also, we were removing coactivity because here we were supposed to excavate in many places, and it was also risky. And then from a planning perspective, it was more or less identical. So at the end of the day, after discussion with our engineer and client, we went with this solution. From a construction perspective now, so this is the cavern where we are assembling the TBM. So during the last autumn, we assembled the shield, as you can see on these small movies. We assembled the shield here, first with the gantry and then all the pieces of the shield. And during the same time, we were still excavating within this part of the cavern, as you can see here. And also, at the same time, we were excavating here, on that direction, just to locate the backup here. So basically, this is the configuration we were in November, and I would say everything was okay. And here you can see the TBM assembly, the shield TBM assembly, just in November when we put the cutter head at the final location. But we got some issue with the technical cavern some weeks later. Or just a few words about this technical cavern. So basically, it's 25 meters by 20 meters. We are 700 meters below the ground level, and as introduced by Adrian a few minutes before, we are in black schist with some local, with some sandstone and pellite. Ground condition basically around 60 MPa, and we know that we will have poor ground condition with GSR around up to 35. Support bolt with basically around 1 bolt per square meter, lattice girder, shotcrete, and also fuse layer. We made all the model required and so on, 3D model and so on, because there was an intersection. And at the end of the day, we made this excavation. So we went with fuse layer because the ground is too soft, and if we don't bring this fuse layer, the shotcrete will have been overloaded. And here you can see the benefit of this fuse layer, because here you can see there is a lattice girder, and this lattice girder is locally crushed. So it was our expectation, and we got our expectation, so we were happy. So everything was okay, except that while we were excavating, we completed the excavation of top heading and straws, and while we were still excavating in this area, we could see that it was difficult to manage the convergence. And end of November, we were around 35 centimeters of subsidence at the vault, and there was no trend to stabilization. And there were more, I would say there was a trend of acceleration, because at that time we were between 5 millimeters per week of drawdown, and it was increasing a little bit, and we went up to 10 millimeters a day. So beginning of December, we decided to backfill the cavern around on 8 or around 6 meters, and to implement additional new bolt, 12 meters. Why 12 meters? Because it's the master class. It's difficult. Usually, as Adrian told us, when you do 12 meters, it's always working. So we went with 12 meters. And that's true, because we switched from 10 millimeters a day up to now, today we are around 1 millimeter per week, a little bit less than 1 millimeter per week. So this 12-meter bolt, at the end we have 1,500 bolts to perform, and today we have implemented around 800 bolts, and we are still bolting in the area. This is a picture taken beginning of this week. So we are bolting. Just some word about the progress on the other part of the project now, on the emergency station, LAPRA. So now we are excavating on 4 heading, here, and here. Basically, in fact, we began the excavation around 1 year ago. And now we are in this emergency site. In December, we excavated 100 meters, so you could say it's not so much, but you have to keep in mind here we have now, we are in top heading, and we have large section with top heading. Also, we are in schist on sandstone, so we are bolting 8 meter, 12 meter, shotcrete, lattice girder, so it's quite difficult condition. But and in addition to that, in December, we stopped the work around 23 of December for Christmas holidays. On the west side, here we have two different configurations on CO7. So on the west side here, we are working in quite good condition because we are in limestone, so everything is beautiful. Mid of December, we made 32 meters in the week on one face. So it was a good beginning. Again, we still need to go faster, but it's a good input. But we know that we have to fear water inflow on karst. On the east side, so we're in December, we essentially made some reinforcement. Also, we have already done some cross passage here from the existing tunnel, and we have not yet begun the excavation in the central zone on the so-called houiller, but it will come in the coming months. Just some word about conclusion. So logistic is key, especially for such projects. So logistic, underground logistic, but also on surface. As you could see on the picture from Adrian, on surface we do not have so much space. In fact, in Lapra, on CO6, we have only 20,000 square meters, while on CO7 we have 40,000 square meters. For such a project, it's definitely not enough, but at the end of the day, we are within a small valley. It's difficult to find some space. Logistic in surface, it's quite easy. It's a challenge, especially when we are in transition zone. Here, it's a conveyor belt tower. We have two conveyor belts which are coming from the east side, one from the west side, one from the left side, and then we have two conveyor belts. So it's a huge tower. We need to succeed to go within the available space. We need to keep some headroom, so it's a challenge, and definitely logistics is a challenge. Keeping in mind, we also need to arrange with ventilation issues. For such project, we need experimented workforce. Basically, today on the project, we are 1,300, and within these 1,300, we are basically 400 on the top management side. And the other are workers working on site. We are working for 24 hours per day and 7 days a week. And basically, yes, we need some additional experimented workforce in France. In fact, there have not been so much project like that during the last decade. So it's difficult to find experimented people, and definitely it's a challenge for us. Also, flexibility for such projects and anticipation are mandatory. It's a key driver. We have to keep in mind we are deep. It's difficult to anticipate everything. This is just a picture from yesterday. We are on CO7 on the very nice ground condition. So this is a picture from yesterday. So everything is beautiful here. We have dolomite and limestone. Expect that just below here, we have a huge water inflow. We have 25 liters per second now. So we stopped the excavation yesterday evening, and now we are preparing for grouting all this borehole, because that's exploratory borehole we made, and at the beginning there was not so much water inflow, and during the last hours it increased a lot. Basically, it's because we think we have anticipated a karst, and with water coming from we don't know where, but now we have to manage this issue. Thank you.
Thank you very much for your presentation. So I'll take the first question, please.
You want to raise your hand?
It's Peter Townsend from Mont MacDonald. Thank you for a fantastic presentation. It's really good. Can you just explain about the TBM launch? And does all the TBM have to go down at it? And how do you sort of get heavy weights down that tight corridor? And how do you get the segments down to the TBM?
You are referring... I don't... No, c'est bon. So you are asking how do we... you want more detail about how do we assemble the TBM within the cavern, that's right?
Yeah, and how do you get all the materials down to the adit, through the adit?
So we brought the different pieces of TBM through the adit. At the end of the day, within this adit, we have a clearance about 7 meter width by 4.5 meter height. And we designed the TBM pieces we go down for such headroom. And it was okay. There was not so much space, available space, but it was okay. And then when we preliminary assemble this device, and as you can see on this sketch, we bring all the small pieces and then we assemble it within this cavern. So it's 20 meter by 20 meter, and then we have such arrangement. I don't know if I'm answering your question.
Yeah, pretty well. Just the other thing about segments, how are you going to get the segments down?
Okay. So segments, then later we will bring the segment with MSV going through this adit. And in fact, here we have an enlarged cross passage, and the MSV will go through here, up to there, and up to this tunnel we are going to excavate. Regarding lining, we have 50 centimeter thick segment. We have an arrangement with 8+0, and the ring length is 2.2 meter. So it's quite long ring, yes. And the idea was to get a longer ring as possible, just for logistic issue, because we know, especially on the other side, the logistic of the segment will be difficult. So during the tender, we were more with a 1.8 meter segment, ring length, and we decided to increase to 2.2 meter just for logistic issues.
Thank you.
Okay. Could you knock the lights down, please, at the back, the spotlights? Hard to see out.
Thanks, John. Steve Parker, Keystone Tunnelling. 2 questions.
That's better.
On the squeezing ground, what allowance do you make over the years? Obviously, you've got for the train a kinematic envelope that you must achieve for the trains to travel through, yet you're talking about some big movements over weeks and days and months. So when you're doing your design calcs, what do are you ending up with a tunnel that is 2 meters bigger around the kinematic envelope that you require, or is it 1 meter, or will you say, well, if it squeezes in and comes in, we will go back 5 years later and make it bigger? How do you calculate that? And then in the tunnel area where you're using the segments, how thick are they? Because presumably they are also designed to stop the squeezing ground.
So first, there is now a huge background because now from this adit excavation, as you can, here is a picture from the adit. This adit was excavated 20 years ago now, and now we have some knowledge of the adit because many people work on this on the constitutive model, on how it is going, and they could demonstrate that with there is some viscous law. With some viscous law, we can. It's possible to anticipate what will be the movement of the ground. So basically, the idea is this squeezing ground are at the end quite heterogeneous. Sometimes we have 1 meter, like this, and locally, some meter away, you can have only 50 centimeter. But with the idea basically is you excavate, you put a lot of bolts, definitely, 8 to 12 meter long bolt at the face also. When we are in very poor ground condition, we do this pilot tunnel. And with this bolt, and sometimes the bolt also, you need to rebolt later because the bolts are crushed. And then you can see that there is an asymptote, there is a trend to a stabilization. And as per some constitutive law with viscous model, we can demonstrate that at that time, if we bring a final lining around 1 meter, 1.2 meter, you will be in position to manage all the load and the stress during the next 100 years, basically.
Okay, so it squeezes for 2 months, 6 months, a year, then
Yes.
stops, or ceases, or...
Yeah,
okay.
yes, true.
Thank you. And the segments, how thick are the segments? How thick are the tunnel segments?
The lining within this area is 1.2 meter, and the segment is 50 centimeters, and the TBM, we have not introduced that, but the TBM is designed to work with 2 segment thickness. So the idea is to work with 50 centimeter thickness on, let's say, 95% of the alignment, and when we encounter a fault, we can switch from 50 centimeter to 60 centimeter. Also, we can switch from a C50 to a C80 MPa. So that's the idea in case we're encountering a fault.
Okay, thank you.
Thanks. Dan Garbutt, Nuclear Decommissioning Authority. Did you, as you were sort of coming into the design phase and sort of setting out the requirements for your tunnel, did you work with any other sort of parts of the research sector within France, for example, Andra, and the work on compressible linings that they're doing with the University of Gustave Eiffel? They've set up some really interesting experimentations that have been looking at how they can use segmental linings in their repository, CGOP. Did you do any of this, any collaboration ahead of time to see if any new technology could be implemented in this project, or is it a...
There was a preliminary works during 2015 and 2019, where there was a gallery that was called SMP4. SMP4 was an exploratory gallery at real site conditions. So in this phase of the project, we experiment lots of techniques, also with university in France, also in Italy. And all these results are taken and recalculate, reassembled, etc., to make the detailed design for this part of the project. Also, I have to keep in mind that the parts that was made for TBM was not concerned by these challenges. These challenges were only on specific parts of the project which were made with drill and blast method. So the segments, in fact, are not really concerned by this problem, in fact. So yes, the answer is yes. We made lots of experience, lots of tests on various materials and various techniques to find the best solution to pass through these conditions.
Yeah, Eric Kukai, design manager for Skanska on HS2. I have a question from a contractual perspective. I'm not sure whether you mentioned it, like what's the suite of contracts that you've adopted for the project? Because obviously on HS2 we've adopted the NSA3 and government and HS2 are a lot under pressure to, well, not to clarify, but the contract has been questioned why the project has been over budget, and one of the reasons is actually the suite of contracts that has been adopted. So what are you adopting? You mentioned that the client will take the geological risk, and then the contractors the execution risk. So yeah, can you expand and elaborate a bit more on the contract that you used and how does the payment mechanism work?
Okay, just try to answer. The contract is, the base of the contract is this risk share. This is the base from the contract. To do this risk share, you have to have some instruments. It means you have this big, how you say, this big observation. No? It's a lot of observation and in situ what you really see on site now that you can react fast. But it's not a design and build. It's a
Detailed design.
Detailed design. No, it's you have.
Detailed design, build.
Detailed design from the contractor, and the execution is made from the contractor. But
is it a bespoke contract or is it part of FIDIC or?
Oh, it's inspired. It's a kind of contract that inspired Emerald Book. It's inspired also with by Swiss experience also, and the idea is to take time in consideration. So there is a theoretical model. This model is make some clauses in the contract, and then there is a real estate, and the contract adapts to this real estate based on the rules given in the contract.
Okay. And next one on assurance. What's the assurance strategy that you've adopted for design and construction? Is it self-assured, like do the contractors self-assure the design and then construction, or how does it work?
From the owner point of view, from the company point of view?
I guess, yeah, probably both. I'd say probably I see it from the contractor side, so I would say probably like, yeah, the JV between Bonsi and Webuild. How do you assure, yeah, your design and your construction, your works?
It's quite the system of assurance is quite different in France and in other countries in Europe. So we can say also that there is a distinction between what is on the part of the owner. Typically, the geology is the part of the owner. So us TELT, we assume if the geology changes, based on a geological model, based on a risk register, and on the other parts, the company assumes the part of the logistical aspects and the choice of the methods. And there's not any system of insurance that gives one part of the other.
And just it's pretty difficult to find an insurance that is going for a big project like that. No, this is I think they're Swiss or have some insurance for that. It's pretty expensive.
Okay. I'll take one online and then one question down here, yeah? So this is from Leon Hedwig. What drove the choice to select single shield TBMs?
Good question.
Long answer, maybe.
First you then.
No. So maybe first, here there was an existing drive made by previous contract. So when we are doing the other drive, we don't have so much geological risk. Then we know where we are going, and for this direction, for this location, segments was considered as the best option. After, do we go with double shield or single shield? We went with single shield because in France, first, double shield is not so used. And the idea was also to get a compact TBM with a shield length quite minimum. In fact, we have 10 meters only. So the idea was to get something quite small with a huge conicity. And with that, we said, okay, look, there is not so much risk. We can go with the single shield solution. For that location, during the bid, it was open. In other words, we could either go with a gripper machine or a shield machine. From the contractor perspective, we finally decided to go with a single shield machine because we were, after analysis of the existing, but not so much borehole in the area, we said we came to the conclusion that ground should not be so much different on this part than on this part. So finally, we decided to go with single shield machine. There was some benefit also because we have 3 similar machines. And again, here we have a quite huge conicity, a very small shield length. So we were very confident it will work.
We'll see.
Swiss prefer a gripper.
Yeah.
No, it's a big issue that we are discussing actually almost every day.
All right, next question.
Yeah, thank you, Panapalam Likeshwaran. It's interesting that you actually said completion is somewhere around 2032. So the simplest question is, do you really believe you will meet that target date of 2032? And if so, how have you defined trying to bring it from construction to actually having the fully fixtures operational? What sort of time frame have you allowed for in your program?
Depends, because we have different parts of the project, and every part goes with different advancement rate, etc., different technique, etc. So we made the choice to separate those different parts of the project. So the first part would be completed by 2027, 28. The other may make a little more time, and after one part is completed, then the operation can begin for this part. So today we have opened the new contract for operation. And the idea is to collect and to have the response of the company based on this hypothesis. So today, yes, we are confident that we will complete some of the section. I hope almost all the sections. For sure, it will be difficult for those sections who will finish their work with also taking consideration lots of difficulties from a geotechnical point of view, but in your future we can be also confident.
So which goes back to the question of risk.
Yeah.
My question sort of comes back at it. If you can't convince the date,
Yes.
there will be extra risk,
Yes.
which means that in terms of the geological risk is understood, the values that you presented for those sections are to a certain extent accepted. So will the project overrun, and who will bear the cost of the overrun?
Yes, we will support this cost, obviously, because I said the geological risk is on the side of the owner. So if there is some extra cost or some extra time due to the geological part, so the owner supports this cost. Of course, it will have an impact on the operation, on the opening of this section, but you are aware of this risk today. And it's a part of the project, it's a part of the contingency, etc. And we consider all these aspects today, yes.
Okay.
Thank you.
One there. Yep.
I had two questions. One, you've placed quite a lot of emphasis around fire risk. Within the tunnels themselves, obviously you've got quite a lot of machinery. How much of that machinery is electric rather than sort of diesel, petrol? And is that a big consideration?
TBM are supply. We have power supply from surface. But for regarding the TBM, we have power supply from surface, and all the vehicles which are working within the tunnel are with.
Or electrics, no? For
No, they're not.
gas, just when you move the vehicle is diesel, and when they're working is electric. I don't know. Was that the question? Or? The main engines, the main vehicles working with electric when they work on workstation, but when they move, it's diesel.
We do not have any battery, and the idea is not to work with modern battery with lithium and so on, because we know that in case of fire it will be difficult. So that's I don't know if that's answering your question.
It's still an issue, you know. Maybe the question was that we have vehicles that are electric vehicles, no, or they transport a segment.
I hadn't really thought about it from the lithium-ion perspective. I was more thinking about it from having flammable materials on site, like diesel and petrol, that could cause a fire risk. But obviously, being in a tunnel, you've got the ability to hardwire your electricity supply anyway, so you wouldn't need to necessarily have battery power.
Well, every vehicle is a fire risk, actually. You know, all vehicles have self-extinction systems, but you never be sure that you don't can have a problem. TBMs normally are. It's not a problem. The vehicles not. The problems that we have in tunnels is the small vehicles, the transportation vehicles for personal, when they have an incident. Or but it's not more than other projects.
And just one last bit. Obviously, most of that tunnel is within France. Is the cost of the tunnel sort of more evenly split, or is France having to pay a higher burden because most of the tunnel is within their territory?
Si la France paye plus. Si la France paye plus, il y a quoi, 60%?
Non, c'est l'Italie qui paye plus.
No, in fact, there is a repartition that is quite a bit different. Europe takes 40% of the project for the cross-border section.
For this tunnel.
For this tunnel also, and France supports 25%, and Italy supports 35%. So this may be quite strange, but you also have to consider that there is a global section between Lyon and Turin, and the French parts of the section is longer in the French side than in Italy. In the French side, there is almost 60 kilometers of tunnels. In Italy, it's a global section of 50 kilometers without any tunnel. And the financial repartition is that the French side is totally financed by the French state, and the Italian side is totally financed by the Italian state. So that the French side has will cost much more than the Italian side. So to equilibrate this, the repartition for the cross-border section is on the disadvantage of the Italy. That's the reason. So globally, in the global project, the repartition is almost equivalent.
Thank you for that.
Okay, one online here now. This is from Dawood Thambi. It says, thank you for sharing your knowledge on the project. Really captivated by the works, including TBM assembly inside the tunnel, drill and blast activities and anchoring. These are a few questions, but I'll pick out a couple. TBM stoppages. What are the major stoppages for the TBM in terms of geotechnical or unforeseen ground conditions?
First, we are going to do some exploratory holes. That's mandatory, and we always have exploratory holes. Now, if we encounter an unexpected ground condition, we will have a look. That's the unique answer.
All right.
But the biggest risk we have is squeezing, actually. Squeezing is one of the risks that we have to see now.
Yeah.
But you have to keep in mind that there was first a preliminary drive, 8 kilometers long, and on this drive, they were stopped one time, some 200 meters after the beginning of the run of the TBM, and because they encountered a fault, and so we have some background and back analysis from this event. And when we designed our TBM, we added more torque on the TBM. We increased the conicity because the conicity of the other TBM was around 50 millimeter. Now we have 300 millimeter, and definitely 300 millimeter. It's a huge amount. And with that, we are, I would say, quite up to date, quite confident we can manage with this squeezing ground and fault event if we have some fault on the alignment.
All right. I'll maybe take one more and then we'll finish up. If there's anyone else who's got a question. Yeah.
Andrew Smith, I'm on the committee of Management Committee of Tunnel Skills. I just wanted to ask for basic information about how you recruit, train, assess and certify the competency of your workforce.
Huge challenge because at the difference of what have been done in UK with Crossrail Academy, for example, here we don't have any. There is no academy so the workforce is coming from everywhere and nowhere, I would say. Now, in the past, in this area, first we are in the Alps mountain, and there is, from the last 30 years, there are some tunneling activity within this valley, within this area. First, there have been some activities on this tunnel from now 20 years. Okay, it was smaller, it was a quite limited activity, but there was some workforces. Some years ago, there was also there is a so-called Fréjus tunnel. It's a road tunnel, a 12-kilometer long tunnel, and this tunnel has been a new tunnel has been excavated. Then there was some activity, but definitely, so there was a small workforce, local workforce in the area, and then we need to find other people from everywhere, I would say, and that's for us a huge challenge, and definitely, yes, that's a challenge, and which definitely is difficult because in France, as I said before, on the last decade, we excavated, let's say, 1 kilometer of drill and blast per year, and now we have, because there is our lot, but there is the other lot with also a huge drill and blast activity, and for drill and blast, it's difficult. For TBM, it's not so difficult because, for example, in Paris, there was a lot of TBM in activity on the last years, during the last years. So we think we will find people easily, but for drill and blast, it's difficult to get correct experimented workforce.
Maybe just a small information now. Now in Europe, a project like this size needs like altogether, say 10,000 people now, big project. But what we don't have to forget in Europe, like the southern of Italy, they have big investment now. They have 19 TBMs are working the same time now in Sicily, and all these big projects are like 10,000 people. In The Brenner is ongoing. The base tunnel Brenner is like same size almost. 10,000 people now. Then in Norway is going a lot of work too. This is I think we have a lot of investment in underground structure, and we have a problem to have qualified like miners. Miners is when you want to have a future job, do miner, I think.
To illustrate this challenge, you can also say that at the peak of the activity, we expect 4,000 workers on this project. And in the valley, in the French side of the valley, the global people of inhabitants are 40,000 people in the valley. So 10% of the people that are in the valley could almost work on the project. So it's huge. And also for this system, the state has set up what is called the démarche grand chantier. That is a system that is accompanied by the authorities to facilitate the job, to facilitate the contract with the company. Obviously, it's not the only solution, but it also helps to make people in contact to face this challenge also.
Okay, well, thank you very much for coming over and presenting a fascinating project. Wish you well with the remainder of it. So. Right, I'll try and rattle through a couple of slides. So first, I'd like to welcome the Norwegian Tunnelling Society here. Do you want to stand up quickly, say hello to everyone? They're on a 3-day visit, so you'll be in the bar after, yeah? All right. And, we also have Helen Roth here, who's just been brought onto the International Tunnelling Association executive member. Is that right? So there's Helen. All right, moving on to the slides then. If you can take them, have I got control? All right, yeah, thank you for our sponsorship. Vancy doing the drinks and ARX are doing the food. And particular mention to, let me get this right, Morgane Bertrade. She helped to set up everything today, and she's also co-chair of the AFTES Young Members, whatever that stands for. So, is she? You here tonight, Morgane? She couldn't come. No? Oh, okay. A shout out for her anyway. Okay, next slide, please. You got it there, have you? Yeah, books are available. We've been getting fantastic feedback from people who've read the books, pictures of them, reading it with the Christmas tree in the background, and yeah, well, you can see it there. And there's a call for pictures as well. If you've got any pictures showing you in the book and a giant teddy bear or something, send it in, please. But yes, £65 now. It's still fantastic value for 900 pages of tunnelling history. Okay, thank you. Next one. Yeah, there you go. There's the book again. Next one. Right, Thursday the 30th of January. So this is Young Members. World's longest tunnel constructed by a single TBM. So very relevant to what we've been hearing tonight. Yeah, that's on the 30th. That's in person here, but it's also being broadcast online to Arab's office in Birmingham. So quite a nice initiative there to widen the scope of our presentations. Yep, next please. So Wednesday the 12th, another Young Members, is a sustainability training session which has been held in Birmingham. Okay, next one. And then here, next month, 13th, we got the Woodsmiths project, evening presentation in person here. Okay, next one. And then Thursday, the 6th of March, there is Young Members BREEAM Infrastructure Lecture, Thursday, the 6th of March. And that also coincides with a post-lecture International Women's Day celebration. So a combination there sounds really good. Good initiative again. Okay, move on. Harding Prize. So the successful people who prepared the papers will be speaking here. So the closure date for entries is the 31st of January. If I can ask everybody, if you've got any junior members on your teams, get them to submit papers, please. It's well worth it. The rewards are really good as well. I think something like £1,000 now for the first prize. But it's also very good experience for young engineers. And the Doug Allenby Memorial Medal. So we had our first presentation of that last year. Fantastic day, great for the young engineer. So we're looking for, the young members are looking for nominations of young members under 35 who are standing out in their career. Again, great bit of recognition. Next one. Okay, so there's a lot here, isn't there? So bursaries for the World Tunnelling Congress on 2026 in Montreal. BTS will be offering 2 bursaries of £1,000 each, and there's eligibility there. So if you want to apply for that, can you submit to that email address, bts@ice.org.uk, or I'm sure you can just go on the BTS website and you'll get the information as well. Right, next one, annual dinner. Tickets will go on sale in February. It's on the 23rd of May, a usual venue, Friday. Slightly later in the month, but that was the only one we could get. And our guest speaker is the Right Reverend Richard Cole. Next one. So we're just about to start open to take bookings for the week-long design and construction course. Always get fantastic feedback on this. People talk about it for years and years. That's been held at Warwick University, and the bookings will be open from the 3rd of February. So I get in early on that. It's always popular. All right. Yeah, there's a QR code there. It's a lifestyle survey generated from the International Tunnelling Association Working Group 21. All BTS members should have had an email with the link to this to fill it in. So if you could, please, doesn't take long. Next one. This is a call that the BTS have several technical subcommittees and working groups, and entry to that is open to anyone, particularly if you've got particular knowledge or interest in certain subjects and you'd like to get involved. You don't have to be on the committee. Topic for the working group can be adapted, but the working groups technically need support. They've got a lot to do and they need more people. So if you've got particular passion for that, please get involved. Bethan is over there. Bethan, yeah. So Bethan will love to speak to you after. Right, next one. Oh, have you heard about the book? All right, see you in the bar. Thank you, everyone.